Hello everyone, in this video we are going to talk about thermodynamics web. We are from group 16 and now let us introduce ourselves first. Fariha, Nishalni and also Adleena. Let's take a look at the thermodynamics web. Thermodynamics web is a flowchart showing the paths between the Maxwell and cyclic relations where P equals to pressure, T equals to temperature, V equals to volume, S equals to entropy, alpha equals to coefficient of the thermal expansion, Cv equals to heat capacity at constant volume, and Cp equals to heat capacity at constant pressure. Thermodynamics web has cyclic and Maxwell's relations, but what are exactly those two relations?
Okay, what is Maxwell relation? It is equation that relates the partial derivative of properties such as P, V, T, and S of a simple compressible system to each other. This Maxwell relation is derived from four-Gibbs equation that I will explain it later in the next slide. Example of the four-Gibbs equation that I stated earlier. It consists of four functions which is U, H, A, and G. And the natural variables here is the variables that we keep constant throughout the relation. The first one is function u, which is du equal to t dx minus p dv. With natural variable of s and v, we will get the derivative of t over ds at constant v. Moving on to the second function, which is h, we will get dh equal to t ds plus v dt at natural variable of s and t, and the Maxwell relation is dt over dt at constant s is equal to dv over ds at constant t. The next equation is we need to use the function of a. The differential of dA equal to negative t dt minus s dt with natural variable of v and also t. And when we derive this equation, we will get dp over dt at constant v equal to ds over dv at constant t. And the last function is by using g, which is dg equal to v dt minus s dt with constant t and equal to negative ds over dt at constant t. So that is all four functions of Maxwell relation that we can summarize in this video.
Moving on to cyclic relation. Cyclic relation is a formula which relates partial derivative or three interdependent variables. The rule finds application in thermodynamics where frequently three variables can be related by a function of the form f(x,y,z) equal to 0. Each variable is given as an implicit function of the other two variables. This cyclic relation can be written for three related properties like this, where dx over dy at constant z times dy over dz at constant x times dz over dx at constant y is equal to negative 1. For example, the value of dt over dv at constant s can be replaced by the product negative dt over ds at constant v and ds over dv at constant t. The product of this triple product rule is negative 1. This is the step on how to get the triple product rule as negative 1. So, suppose that the function of x, y, z equal to 0, we can write the z as a function of x and y. Thus, the total differential dz is dz is equal to dz over dx at constant y dx plus dz over dy at constant x dy. Next, we move along to curve dz, and y can be written in terms of x. Therefore, the equation for dz will become 0, and when we rearrange all the terms, we will get dz over dx at constant y is equal to negative dz over dy at constant x times dy over dx at constant z. And by dividing by derivative on the right hand side, and it will give us the triple product rule, which is negative 1. So how was the explanation earlier? We hope that this video can help you to understand more about thermodynamic webs. That's all from us. Thank you for listening and don't forget to like and share this video.